Hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
Hey there, welcome to another interesting workshop on this time in a topic called as building a content-based recommender system, right? As the name implies, what we're going to do in this workshop is to build a recommendation system for movies, right? So we're going to take a movies data set, and what this system is going to do is based on a particular genre, right? It's going to suggest movies for you, or when you choose a particular movie, right? It's going to suggest you a list of similar movies, right? That's the intent of this workshop. It's to recommend movies based on your choices, on your previously selected choices, right? That's the intention. So let's have a quick look at what we have in store in the list of topics for the workshop. So we have this introduction overview, which you're doing right now. Then we're going to talk about the software and requirements in the next section. Then we're going to download the data set on which we're going to train this recommendation engine. And then we're going to explore and understand the data set thereafter, right? So after all of this is over, the preliminary steps are over. We're going to do the coding, where we have the data cleaning and processing, and then we're going to build the recommendation function thereafter, and then post that at the end, we're going to be finally demonstrating and testing the application that we've built, right? So that's all in store. So with this, let's go to the next section, software and requirements, where we discuss the basic requirements that you're going to have in order to build this workshop. So without wasting further time, let's go there. So in software and requirements, basically what you have to ensure is that whether you have a version of Python which is 3.10 or higher, because all these libraries like scikit-learn, pandas, and numpy, they successfully work on version 3.10 or higher. If you use older versions, then you might have some errors that might pop across. Because most of the libraries have been updated now, so they have updated features. So just download the latest versions, and then just make sure you have a Python version 3.10 or higher. So all these three libraries, they are outside the Python's the standard library list. So you'll have to do a pip install to download them. So please do a pip install scikit-learn, pip install pandas, and pip install numpy, right? So once you're done with this, you would be in a position to then work on the code, which we are going to be writing in the lessons to follow. So without wasting further time, let's go to the next section where we download the dataset. So here we are on Kaggle.com, which is the world's most popular site for fetching tons and tons of useful data sets for your machine learning models, right? So obviously you have to create credentials on this. You have to create your login credentials, and once you've created them, you have to log in using those credentials. And then once you're in, that's when you'll be allowed to download any dataset of your choice. So to download a dataset, just come to datasets on this page. The left hand side, we already here, so you don't have to come. And then in this bar, just search, say, Netflix titles, which is a popular dataset. I mean, a lot of people have basically build their own ones, but then the one we're going to use is this one, right? Netflix underscore titles by this person, which is 1 MB in size. So just click on this one, and then go to download, where you have the option, say, download dataset as zip. Click on that, the option, and dialog box is going to open where it asks you to save it. So just save that, and then you see a zip file is going to be created called as archive.zip. Just extract that file, and then you would be seeing an Excel file thereafter, right? It's going to be called as Netflix titles.csv. It's a CSV file. So in the next section, let's explore what else has the CSV file to offer, right? Let's play with that data set in the next section. So without wasting further time, here we go. Right, so now we explored the data set. We double click the file Netflix titles.csv, and this is what we have. Let me just zoom this in. So here we have. So if you look at the number of columns, we have 12 columns. The first one is nothing else but is the show ID. The second one is the type of the show, whether it's a movie or a TV show. I think we just have two categories here. It's a movie or TV show. Then we have the title, which is the title of the show. Then the director, who's the person who has directed the show. Maybe it's one person in most cases, or many people in some cases. And we have the cast of the show, like who are the actors in the show. Then the country from which the show belongs to. Then the date added, when did it first start screening, and then the release year. I think that should coincide somehow. Like there should be before the date added, right? Because sometimes the movie get released in the theaters, and then they get released on OTT platforms like Netflix, right? So the release year is going to be less than the date added. Then the rating of the show. This rating is actually PG is parental guidance, or TV is like a TV movie, something like that, right? G is general, R is again its own category. I think it's PG itself, right? And the duration of the show, whether it's like a 90 minutes or like seasons, or if it's a movie, then it's going to be in minutes. Otherwise, it's going to be in seasons, right? And listed in this field is really important because this shows the genre of the show. So, whether it's documentaries or international TV shows or TV dramas or mysteries or docu-series or reality TV or something like that, right? That's listed in. And then the last one is description. So description basically talks about a small overview of what content the show basically covers, right? So whether it's basically a description of the show, right? Something which is meant to elaborate on what the show is supposed to cover, right? So that's the description. So this is it. So using this, what you're going to do is at the end of the application, what you will be doing is you'll be typing one of the shows from this list, right? This list is, I think, close to 8,000 rows in length. So out of these 8,000, you're going to be just typing one of the shows of your choice. It should be from this list. And then what the application is going to do is it's going to suggest to you similar shows or similar movies that have the same genre, or they are like similar in nature to the show or the movie which you have selected. So like it's kind of a recommendation system, right? It's a content based recommendation system. Clear? I mean, that's what the application is all about. So you're going to train this the application on this data set, wherein it learns the title, the director, cast, and then the listed in the genre from this data, and then based on that it suggests you the similar titles based on your genre, right? And then that similarity score, right? So let's get into the next section where we now start coding, right? So here we go. All right, so now we start coding. So before we begin coding, let's open a Jupyter notebook in the same location where you have saved the file. So by doing this in this file, right? So by doing this, you do not have to specify the actual path in the code, right? You can work in the same directory. So let's open a new notebook here. Say notebook, and then uh, let's save this as name, right? So here's the thing. It's loading now, right? So here's the thing. So let's start importing the libraries first. So we say import pandas as et, then import numpy as np from scalar dot feature dot feature extraction text. Right, so from scalar dot feature extraction dot text import TF-IDF vectorizer. Okay, that's so TF-IDF is basically term frequency, inverse document frequency. So we would study this metric later in the next section when we actually code it, right? And then from scalar dot metrics dot pair wise import cosine similarity. All right, so we have imported everything that we require. So let's run this part. Right, we're good to go. Now we load the dataset. Right, so let's say df et dot read csv Netflix underscore titles dot csv. Right, so let's wait for this to run. Okay, it's saying file not found. Oh, okay, I think there's a misprint here. It should be Netflix, right? Yeah, so now it's run, you see? Right? So next thing is, so the next thing in this section is going to be your data cleaning and pre-processing, which we're going to do now coming up next. So let's go to that section. So in this section, we do the data cleaning and pre-processing, where we're basically trying to rebuild that data set in such a way that it becomes it comes to be in a position which can be easily consumed by the algorithms further, right? So let's clean the data and pre-process that. So this basically involves like many steps, like removing empty strings and then splitting the list into its subsequent strings. So let's do it. Let's write the comment in the comment box that says data cleaning and pre-processing. Fill in relevant columns with an empty string. So I think this comment itself explains, right, what you're trying to do. So we say features equals director cast listed in and description, right? So within these features, within all the features, we are going to select only these 4 features because they are the key features that basically determine the dataset, right? Determine the main content within the dataset. So we are going to focus only on these 4. So now what we do is for feature in features. So we are looping through every feature. We say df feature. Sorry, not the inverted commas. It's just df feature equals df feature dot fill na. All right. So what's going to happen is that it's going to loop through each of these features, and then wherever it comes across uh, any NA within any column, right, it's going to fill that NA with a blank, right? That's what it's doing. Fill NA and with an empty string in every column, right? So let's run this. Okay, let's press enter and then, or maybe let's run this part. Then we write a function to get up to 3 names items from a comma separated string. All right, so what are we trying to do next? We are trying to write a function which will say if you give a list, right, as an argument to the function. Suppose the list is having, say, more than 3 elements. It's going to truncate that list up to a maximum of only 3 elements, right? That's the intention of writing this function, right? So we do not want to be making our analysis based on more than 3 items from a particular column. Let's say if the column corresponds to, say, cast, right? Then we want to choose only 3 people from the cast, right? And not all the people, because otherwise our data set becomes too heavy, right? So that's the intention of the function. So let's continue this and simplify them by lower casing and removing spaces. Example, let's say, I mean, this is just for our reference, right? It's not for Tom Tom Hanks become. So we do 2 things in this function, right? We do the first thing which we just discussed, right? Get up to only 3 items, maximum 3 items, and then we also remove spaces from them like this, and then convert the uppercase to lowercase thereafter, right? I think this example makes it clear. So this is what we're going to do to every single uh, item in that column, right, which is passed as an argument. So typically we want to apply this for, I think, for cast and for listed in, maybe even this to some extent. So here we go. Let's write the function now. So def get list limit and clean, right? So it's doing 2 things, getting the list limit and then cleaning it. So object is the argument, then limit equals 3. That's the second argument. Right now it's hard coded to 3. We can, I mean, the default value of this argument is 3, but then we can change it later. Right, so L equals object split. So we split the column based on the comma separator. So items in a column are going to be separated by a comma, right? So we are going to split the column based on the comma. So suppose you have item 1, comma, item 2, comma, item 3. L is going to return item 1, item 2, and item 3, because we are separating it by these commas, right? A list basically. So now the next thing we do is if length of L is greater than limit, in that case L equals L limit, right? Simplify means that's the next step. Return, yeah. Uh, so we replace a space with a blank for X and L. Okay. All right. So for every item in this list, we are replacing space with a blank. All right. That's what we do. And then, so if we have written this function, the next thing we want to do is apply this function. So let's run this function first. And now we want to apply this function to director, cast, and genders, all three columns. I mean, listed in, right? So apply the cleaning to director, cast, and genders. And let's say director is kept as a list for easy concatenation later. So the column director is being kept as a list just to make sure that we can easily concatenate that, because the rest, all the other columns are lists, right? So list, list, list is being concatenated, right? Together. So df director equals df director dot apply lambda x so x dot lower dot replace, yeah, right, space with a blank, right? That's what we do. Df cast df cast dot apply. Now here we apply the function, right? Get list limit and clean. So what this line is going to do, this line is that it's going to take df cast this column as the input object, as the argument, and then apply this function to the entire column, right? So this column is going to be transformed based on this function, where only the first three items of the list, right, are going to be picked up. Basically, up to three items from any value. I mean, from the list is going to be picked up, where a list represents every column, and then that list is then thereafter going to be cleaned. Every item is going to be cleaned. So this, right, is going to return a new list where every item is going to be cleaned. Cleaned in the sense it's going to be transformed to a type where all spaces are going to be removed, and then the uppercase letters are going to be transformed to lowercase letters, right? All right. Next thing you're going to do is say df. Now this is the important column, the gender listed in equals df listed in dot apply, again the same function, get list limit and clean. So these two columns, right, cast and listed in, they contain uh, values in each cell where each value represents a list, right? And this list can get even longer than maybe 3 items, especially the cast, right? And the last one is df description, df description dot string dot lower, right? So say lowercase only for description, right? So with this we finish the, let's run this part. With this we finish the portion that corresponds to data cleaning and pre-processing, right? So in the next section, what you're going to do is we're now going to be starting with the NLP components, right? Where we create certain data sets. We transform this data set in order to make it consumable for the NLP algorithms like TF-IDF and then cosine similarity. So similarity. So without wasting further time, let's get there. Right, say stop. All right, so in this section now we create the weighted data metadata soup. So we're going to create a column called as soup where we are going to be concatenating the columns of interest, where these columns, each of them represent important pieces of information which will assist the TF-IDF and then the cosine similarity for deriving their insights, right? So let's create the function. So let's say create the weighted metadata soup. Right, and then def create comment here is like combines all cleaned features into a single string. The soup character genders are repeated 3 times for weighing. All right, so this is what we're doing. All right, sorry, waiting, right? Just a piece of information, and then so this is basically going to be your director list plus cast list plus gender list, right? Now I don't need this quotation marks, they're not like actual column names, right? So metadata list equals x director plus x cast plus x listed in. So repeat, let's have a comment that says repeat the, where's this is plain concatenation, right? So let's say repeat the high value metadata 3 times for waiting, and then description term. You're joining 3 times, right? We repeat this 3 times just to give an impression of weightage, right, to the items. Plus space plus x description, right? So this is what it's going to return. So this list of these 3 concatenated columns plus, this list of these 3 concatenated columns multiplied by 3, repeated 3 times, and then added to, concatenated with the description column at the end, right? That's the soup. That's essentially the identifier of unique information for every single movie or every single series, right? Every single item in the data set. So we say df soup equals df dot apply create soup access equals 1, right? That's important. Uh, right, so this function is going to be applied to this data frame using df.apply, where all these columns are going to be automatically fetched, and then this new column is going to be the transformed column. It's a new column created by concatenating the constituent columns from the data frame, which are director, cast, and listed in, and then multiplying this concatenation by 3, and then concatenating this with finally the description column to get the final identifier, which is soup, right? So let's run this line. All right, it's successfully run. So now let's just check how this looks like. So like print, let's say like gf soup dot head. So you see, it has repeated twice, and this is how it looks like basically, right? Say dot head 10. So you have the first 10 rows here. Okay. Perfect. Beautiful. All right. So in the next section, let's actually start building the TF-IDF matrix, right? Which is going to be consumed by the cosine similarity matrix. Cosine similarity algorithm, right? So let's build that matrix now in the next section. Here we go. All right, so let's do the content vectorization now. Let's write, say, content vector vectorization TF IDF right. So what you do is initialize IDF vectorizer, and then max features, say limits the vocabulary size. All right, so that's what we're going to do. You're going to use max features equals 20,000. So we are going to restrict the vocabulary to 20,000. All right. I hope we all know what TF-IDF does, right? So we won't repeat that theory here. So TF-IDF equals, let's copy from the top, TF-IDF vectorizer words equals English and max features equals 20,000. Then fit and transform the soup. So TF IDF matrix equals TF IDF dot fit transform TF soup. Right. So we initialize the TF-IDF vector class by instantiating it using stop words equals English. So we specify, I mean, we construct it using these arguments, like the stop words equals English. So we're using the English language. And then the max features are 20,000. So what TF-IDF basically does is it's a combination of term frequency and inverse document frequency. So what is term frequency? Term frequency is like how what is the frequency of occurrence of that particular word in that document, right? So let's say if there's a word that says I went to the class. So let's say you have the word class, right? So how frequently does this word occur in the sentence? Just once, right? But then I am a student and there was no student in the class. So in this case, what is the term frequency? The word student occurs twice, right, in this document. So uh, it's going to be 1 divided by 2, right? Oh, maybe. Oh, I'm sorry. Let me correct myself. That's not term frequency. Term frequency is basically the number of words in the document. That's a denominator, and the number of times the word occurs in the document. So in this case, the number of words in the document might be like, say, I think I am a student, right? So these are 4 words, and then there was no student in the class. So these are 7 words. So 4 plus 7 is 11. So the denominator is 11 words, and then the word student occurs twice. So it's 2 divided by 11. That's the term frequency, all right? And what is inverse document frequency? Inverse document frequency is, suppose you have like say 3 to 4 such documents, right? Then what you do is you check in how many documents you have this word student. So now we calculate the cosine similarity. So let's say calculate the cosine similarity. So how do you do this? Say cosine sim equals cosine similarity TF IDF matrix. TF IDF matrix, right? So both the arguments typically involve passing both, I mean, the same variable, right? Because we are essentially computing the relationship of every item to each other, right? So that's why we pass every item to another. So that's why we pass the same argument in both the placeholders. And then let's run this. Right, so this computes the cosine similarity. So let's try to print this. Let's say print cosine sim. Let's say, yeah, let's print this. So here you see it's basically a matrix, right? It's like an n by n matrix where n is the length of this column, right? So you see these values are all 1. because the similarity of every item to itself is always going to be 1. But then the similarity of every item to another is going to be something ranging from 0 to 1, right? So that's what the matrix is all about, right? So let's remove this, and now let's go to the main section now, where we build the enhancer recommender function, right? So this function is basically going to create the uh, recommendations for you, right? So let's start building that function in the next section. So without wasting further time, here we go. So let's do this recommender function. So reset index and create a reverse map for the quick title lookup index, right? So we reset the index here, and then we say indices equals pd.series df.index index df df title top duplicates, right? Then say def get enhanced recommendations. Say title cosine similarity, and let's say just cosine sim matrix equals cosine sim df data equals df indices map equals indices and top n equals 10. Right, so what we do is generates enhanced content based recommendations for given item table, item title, and that's essentially the intention of the workshop, right? So now we write a try block. Let's say get the index of the item that matches the title. So idx equals indices map title, except key error. Return error title not found in the dataset. Please check the spelling, right? get the similarity scores for that item with all other items. That's the next step, right? Say sim scores equals list enumerate. So we use enumerate here because we want to generate a counter for every item in that list, right? That's a Python functions cosine sim matrix itx, right? Then what we do is we say sim sort items based on similarity scores in the descending order, right? So sim scores equals sorted sim scores key equals lambda x such that x1 reverse equals true, because we're sorting this in the descending order, right? Let's say descending order. And then now we get the scores of the top and most similar items, excluding itself. So we say sim scores 1 to top n plus 1, right? Then now we get the item indices. So that's given by right, and then return the titles of the most similar items. Recommendations is okay, it's unmatched and 18. Let's paste the entire function once again. I mean, let's right, so it's run successfully. So yes, here we go. So now in the next section, let's actually test the entire application. Okay, now the application is going to work. So now let's try some sample run in the next section, and then let's see how the application works. All right. So without wasting further time, let's delve into the next section. Here we go. All right. So now we demonstrate and test this. So let's say demonstration and testing. Let's write this down. Let's say we test a TV show, right? Let's say test title one is blood and water. So this is one of the titles in the list that we already had in the data set. And let's say recommendations one is like get enhanced recommendations, test title one. So print recommendations for test title one. Now we write a loop that says for I in rec print rec, all right? And then we say print. I'll just have a placeholder here, okay? Beautiful. You see, so for blood and water, we have these recommendations like more to say, between, gin, open your eyes, switched, tabula rasa, the platform, secret city, girl from nowhere, and kissing game, right? So these recommendations are what you have for this show. Now let's test another one quickly. Movie documentary, and then so this time we're testing a movie, right? It's a documentary movie. So Dick Johnson is dead. So and these are the recommendations for that. So like 9 to 5, Sisters on Track, Murder and Mercy. So this sounds like a murder thriller, right? So these are the recommendations which sound similar, right? So here we go. In this way, we have been able to demonstrate how a recommendation engine is built based on content, right? Using cosine similarity metric. So I hope you like this workshop. For more workshops, stay tuned, and I shall come back with more of such interesting content. All right. So until then, I wish you best luck uh, with your coding on this workshop. Right. Best wishes on your journey on learning. Until then, take care. Bye bye.